everybody, it's Ms. Phoebus, and I'm back with another lesson, lesson 42, the quadratic formula and the discriminant. All right, so we have three skills. We are still identifying the zeros of a quadratic equation using the quadratic formula, but I also want you to be able to recognize when the quadratic formula gives you a complex solution and you would say no real solution. We did an example of that yesterday in the last lesson. And then you can use the discriminant, which is a new word, of a quadratic to determine the number of solutions that a quadratic has. And we're still working on the standard that we are knowing and applying the quadratic formula. We're recognizing when we have complex solutions, and then we would say no real solution. So we're on page 176 in the notes. And on page 176, you have information about the discriminant. So the discriminant is a number, and discriminant sounds like discriminate. Now, discrimination has a lot of negative context, like people think discrimination is bad, which, you know, if you're discriminating against somebody because of their skin color, you can't do this because of your skin color, then yes, that is bad. But what we're doing is we are saying, hey, you're a quadratic. I'm looking at this number, and because of this number, you have to have 1 0. You have to have 2 zeros. You have to have no real solutions. So that number is going to help us discriminate and tell what kind of type of quadratic and how many solutions that it has. So this number is used to determine the number of solutions. So the discriminant is the number of solutions there are to a quadratic, relatively easy. Now, if the discriminant is positive, there are 2 real solutions. Just like when I say, hey guys, we're taking the square root and we're going to take the square root of 49. What's the answer? And I would say, no, it's not 7. It's plus or minus 7. How many answers is that? There's 2. Okay, because the number under the square root is a positive number. If the discriminant is 0, so we're looking at the number underneath the square root being 0, there is 1 real solution. Because the square root of 0 is just 0. You do not get a positive 0 and a negative 0. It's just 0. And if the discriminant is negative, so we're looking at the number underneath the square root, so in this case we have a negative 16. So when it's negative, there are no real solutions. So all of this is about the pieces that are underneath the square root, determining how many solutions we have. Okay, so what the discriminant looks like, it looks like b squared minus 4ac. That's the part of the quadratic formula that's under the square root. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that b squared minus 4ac is the part that's under the radical. If the discriminant is positive, we will have 2 solutions. It will cross 2 times. If the discriminant is 0, it will cross the x-axis or touch the x-axis 1 time. If the discriminant is a negative number, it will not intersect the x-axis. So it's a quick way, instead of having to run through the whole entire quadratic formula, all we've got to do is look at b squared minus 4ac, get that number, and it will help us determine how many zeros we have, how many solutions, how many x-intercepts we have. Now, it doesn't tell us where. The whole entire quadratic formula tells us where, but it tells us how many. And sometimes that's all you need. So it depends on the wording of the question. Where are the zeros? Quadratic formula. How many zeros do you have? Discriminant is enough. All right, so here is our quadratic, x squared minus 2x plus 3. We're going to check the discriminant. So discriminant is b squared minus 4ac. Our b is negative 2. We want to wrap that in parentheses. Minus 4 times our a is 1, our c is 3. And then we're going to go through. You can plug it on the calculator, especially if you have trouble with order of operations. Or if you're good with order of operations, you can go ahead and work through this. So I'm going to do negative 2 squared is 4 minus, and then 4 times 1 times 3. 4 times 1 times 3 is 12. 4 minus 12 is negative 8. This is the discriminant. The discriminant is a number. The discriminant tells us that it's negative, so because it's negative, there are no real solutions. Okay, so let's think about what this looks like. So if I was going to try to find two numbers that multiply to give me 3, add to give me negative 2. Well, it could be a positive 3 times a positive 1, that would give me a positive 3. Or a negative 3 times a negative 1, that would give me a positive 3. But there are no answers. This is unfactorable. If I was going to do the quadratic formula for this, I would have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I would have a negative 2, which is a positive 2, plus or minus the square root of negative 2 squared minus 4 times 1 times 3. That's that discriminant that I just found, all over 2 times 1 is 2. So I'm looking at 2 plus or minus the square root of negative 8 over 2. It's not going to work. But it should also be supported by the graph x squared minus 2x plus 3. Let's graph it. You see how that doesn't cross the x-axis? So we're going to do a little sketch in this box to show that it doesn't cross the x-axis. But that means that we have no real solution because it doesn't cross the x-axis. So no x-intercepts. We're just going to kind of hang it out in space like right about there. And so it has no x-intercepts. It's unfactorable. When we run the quadratic formula, we get a negative number underneath the square root. So if we are already so if we only need to figure out how many times it crosses, you can just do this piece, look at one single number, but everything else should agree. Okay, if my discriminant is negative, I should not be able to factor it. I should see my graph does not cross the x-axis. So all of these things support each other. All right, so let's look at another one, the discriminant. Here's my quadratic, x squared plus 10x plus 25 equals 0. So I'm looking at b squared minus 4ac. So in the first parts of the homework, you are just looking at the discriminant. So I should see the discriminant work, but not having to fully do the whole entire quadratic formula. All right, our b is 10, so 10 squared minus 4 times a is 1, c is 25. So I get 100 minus 4 times 1 is 4, 4 times 25 is 100, 100 minus 100 is 0. So what that means, because it is 0, the graph touches the x-axis only one time. Okay, so remember, when the number underneath the square root, or the b squared minus 4ac, when it's negative, doesn't cross the x-axis. When it's 0, it touches it one time, has one solution, and when it is a positive number, then it has two solutions. Crosses twice. So let's see if we can figure out the solutions. So we could factor this. What multiplies to give you 25 adds to give you 10. 5 and 5. So that means that I have x plus 5, or you can think about it as x plus 5 squared, right? What makes this equal 0? negative 5. So let's graph it. Now I'm going to do just a sketch, a rough sketch, but we're going to compare this. It should be at negative 5 on the x-axis. It should have a point there, and it should be opening up because that a value is positive. Well, let's check it in the graphing calculator. All right, so we're going to clear it out, and then we're going to type in x squared plus 10x. And you should be using your calculator too. The more you use it, the more you're going to be able to use it later to help you out. All right, we're going to hit graph, and do you see how it touches it right there? And it touches it at negative 5. I found that. You could have run the quadratic formula as well. It should give you two values, but they happen to be the same. Okay, so I'm trying to tie all of this together. The quadratic formula, if you can factor, and the graph should all agree. And if you can't factor, that means that there's probably something special going on with your discriminant. Okay, let's look at another one. So here we go. We've got 6x squared plus x minus 15 equals 0. And so we're going to look at the discriminant. Now, just like earlier in yesterday's lesson, if it doesn't already equal 0, you do have to move everything to the same side. So don't think that you don't have to do that. B squared minus 4ac. My b is 1, so 1 squared minus 4 times a is 6 times negative 15 is my c. So I get 1, a negative times a negative. I'm looking at negative 4 times a negative 15. That's a positive 4 times 15 times 6 is 360. So I get 361 as my discriminant. So that's a positive number. So because it is a positive number, the graph crosses the x-axis twice. Now, we're not guaranteed to know, like, is it a nice number? We don't know. But we could look at figuring out what the solutions are. So let's go ahead and do the quadratic formula. Let me sing it for you. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now the nice part about doing the discriminant and then having to run the quadratic formula, there is the piece that we already know is 361. So we don't have to work hard for that. We've already got the work put in. B is 1, so this is a negative 1, plus or minus the square root of 361, all over 2 times a is 6, so 2 times 6 is 12. Let's go ahead and turn that into a 12. 361, let's see, is that divisible? It's not divisible by 2, not divisible by 3, not divisible by 4 or 5. 361 is a perfect square. It's 19 and 19. Oh, look at that. So this is negative 1 plus or minus 19, because we have the pair of 19s, all over 12. So I've got negative 1 plus 19, that's 18 over 12. And I've got negative 1 minus 19, that's negative 20 over 12. So reduce our fractions, 9 sixths, 3 halves, and negative 5 thirds. So we do have two solutions. They're not super nice, but they're not super terrible either. All right, so let's look at the graph. So we should expect, so let's say that's 1, that's 2. We should expect having a 0 at negative 5 thirds. So somewhere right about here. And then we should expect 1, there's 2 that's positive. The other ones were negative. And one right back about here, our A values, positive. So we should expect something that looks kind of like this. That's what I would expect. That's like a very, very rough sketch. Don't recommend doing that a whole lot unless you really, really need to. All right. Y equals, clear it out, 6x squared plus x minus 15. All right, graph it. Yep, look at there. It's between 1 and 2, and it's between -1 and -2, but closer to -2. Look at that. I really like my graph. It does go down low. I don't have it marked here what my y intervals are, but it does go down low, and it will turn around somewhere down here and come back up. Okay, but that's what we're doing. We're looking at the discriminant, and the discriminant, if we can learn what that number means. So if it's a positive number, means 2 solutions. If it's 0, that means 1 solution. And if it's a negative number, that means no real solution. And all these other things just agree with that. So the graph should agree. Actually going through the quadratic formula or factoring perhaps, that should help. Okay, you have some options. But the thing is that I'm trying to show you that it all ties together. Okay, so if you know what's going on, you can be able to see all that. Look at that. That says less than 56. I didn't change that. Oh my goodness. We're on less than 42. Don't worry about it. Okay, so we're going to describe the zeros. Now, this is different than the last 3 examples. Do you see how it doesn't equal 0? So I do want to go through and show you that it has to equal 0, because if you pull the wrong A, B, and C, just like from yesterday's lesson, if you pull those numbers incorrectly, you'll still get answers, but those answers are going to be wrong. So we don't want to get the wrong answer. We want to make sure that these are set equal to 0. So I would need to add 3x and add 9 to make it equal 0. So let's look at b squared minus 4ac. All right, b is 3, so 3 squared minus 4 times my a is 1, my c is 9. Now, I need this number. I can't just be like, this is how many zeros it is. I want to see what number is making you say that. So 9, a -4 times 1 is a -4, and a -4 times 9 is a -36. So this is -27. So I'm going to give you a second. What does that mean? How many zeros should we expect this equation to have? Because this is a negative number, we should expect no real solution. So let's check it. Let's graph it. That's what we expect to find. Let's double check. Let's see if we're on the right track. X squared plus 3x minus 9. Nope, it's not minus 9, plus 9. All right, graph it. Look, no real solution. So that one number told us that there weren't going to be any x-intercepts. And so if we get really good at this number, you don't need to go back and double check in the calculator unless you really don't feel confident about it. All right, let's look at another one. Let's look at 5. Does it equal 0? It does not, so let's make it equal 0. So it's going to be 3x squared minus 4x minus 7 equals 0. So we want b squared minus 4ac. Our b is -4, so -4 squared minus 4 times a is 3 and c is -7. I don't want you just writing 1 0, 2 zeros, no real solution. I want to know what number is making you say that. That's the discriminant, the number. So we've got -4 squared, that's 16. -4 times 3 times -7. I'm just sticking it in the calculator. I get plus 84, and 100 is, in the 16 plus 84? 16 plus 84 is 100. Nice. So what does that mean for our graph? It's a positive number. This is our discriminant. It's a positive number. And so what that means is that there are two, and we would even go into saying that there are two real solutions. Okay, so two real solutions. So if you read a question and it says, how many real solutions are there? Those are talking about real x-intercepts that you could physically graph. All right, so we're going to play with the quadratic formula a little bit more. More quadratic formula examples, yay! All right, and then we're going to get our solutions. We're also going to explore, make sure we can find what the discriminant is. All right, does it equal 0? It does not. So we're going to move the 2x, subtract 2x. So x squared minus 2x minus 4 equals 0. All right, A is 1, B is -2, C is -4. So here's our quadratic formula. You ready? Got a song for you. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. So let's get that in there. So -b, a -2 is a +2 plus or minus the square root of -2 squared minus 4 times 1 times 4 times 1 times -4 all over 2 times 1 is 2. All right, so let's get that discriminant figured out. Grab my calculator. All right, so I've got -2 squared minus 4 times 1 times -4. You can shove it all in a calculator. So I get 2 plus or minus the square root of 20 all over 2. So can you tell right now what the discriminant is? The discriminant is 20, not the square root of 20. The discriminant is 20. And so what does that mean? That means we have two real solutions. Okay, so that would mean that if we graph this, then we would see it cross the x-axis 2 times. But these solutions aren't simplified yet. So let's simplify this. So the square root, the 20 that's under the square root, that tells us how many solutions. Now we want to know where those solutions are. So 20 breaks down into 4 times 5. 4 gives us a pair of 2's. Okay, so I'm going to come up here. I've got 2 plus or minus 2 square roots of 5 all over 2. And we're going to simplify just a little bit more. We're going to look here, and here, and here. And what we're going to do is we're going to see if can we divide all those numbers in the green circles, can we divide them all by the same number? And we can divide them by 2. So we will have 1 plus or minus the square root of 5. And that's actually, I should have written that right down here. 1 plus or minus the square root of 5. Those are our solutions. Those are our answers. Now, they're not nice. They're going to be really weird decimals, but that doesn't matter. There's 2 of them. They're crossing the x-axis 2 times. So just because, like if we tried to factor this, we wouldn't be able to factor. It would be considered unfactorable. But that doesn't mean that it's automatically no real solution. It means that the numbers are just not nice to play with. All right, so what do you guys think about 7? Does it equal 0? Let's make it equal 0. So I would add x squared. You want to get everything on one side. So 9x squared plus 4x minus 16 equals 0. My a is 9. My b is 4. My c is -16. And so questions like this, like on the test, they're going to have a quadratic and they're just going to say, how many solutions are there? Look at the discriminant. And so then they're going to have discriminant numbers. And then tied to that, they're going to have like a discriminant answer. Like, the discriminant is 25. That means that there's no real solution. The discriminant is negative 12. That means there's one solution. And so they're trying to mix it up and try to get you to figure out what is the discriminant and then what does it mean. All right, so let me sing the quadratic formula for you. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm a little tired. It's been a long day. This is negative 4 plus or minus the square root of 4 squared minus 4 times 9 times negative 16 all over 2 times 9. 2 times 9 is 18. Let's get that in the calculator. 4 squared minus 4 times 9 times negative 16. We get 592. So negative 4 plus or minus the square root of 592 all over 18. So what is the discriminant? Can you tell? The discriminant is 592. And so what would that mean? It's positive. That means that there are two real solutions. All right, so then let's actually figure out what the solutions are. Let's see if we can break down that 592. So I'm going to do this over here in blue. So I know it's even, so it's divisible by 2. So it's 2 and 296. And that's even, so there's another 2 and 148. And that's divisible by 4. 4 and 37. 37 is prime, but I've got another pair of 2s. So 2s, 2. So I'm going to take out a 2 times 2. I'm going to take out a 4. So I have negative 4 plus or minus 4 square roots of 37 all over 18. Okay, so we're looking at negative 4, 4, and 18. What can we divide all of those by? Evenly. We can divide by 2. So negative 2 plus or minus 2 square roots of 37 all over 9. And that's our solution right there. There's two real solutions, and that's where they're located, at negative 2 plus 2 square roots of 37 over 9 and negative 2 minus 2 square roots of 37 over 9. One gets the plus, other gets the minus. All right, so let's look at number 8. It doesn't equal 0. Let's make it equal 0. Add 6, so we've got 5x squared plus 3x plus 1 equals 0. So A is 5, B is 3, C is 1. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Right, negative b, negative 3 plus or minus square root of 3 squared minus 4 times 5 times 1 all over 2 times 5 is 10. Let's go ahead and change that to a 10. All right, so I get negative 3 plus or minus the square root of 3 squared minus 4 times 5 times 1 is negative 11. Ooh, all over 10. So what's our discriminant? Negative 11. What does that mean for our solutions? There aren't any. There are 0 zeros, which I really don't like. So there are no solutions, but let's just write none, because our solution is no real solution. And we could check it by sticking 5x squared plus 3x plus 1 in the graphing calculator. Does it not intersect the x-axis? And if that's true, then it's no real solution. They should back each other up. You're not going to get some working sometime and others not working. All right, guys, that's it for this video. More quadratic formula. Yay! Hopefully it's getting stuck in your head. And We just need to work more with it because you're not going to get that formula on the ACT. You're not going to get it on the end of course. You need to get it in your head somehow. So that's why I keep bringing up the song. Listen to the song. Embrace the song. You don't have to sing the song if you don't want to, but you can play it in your mind. Miss Phoebus plays the song in your mind. We'll see. All right. Bye, guys. See you in the next video.